All right. So I think I have it now. At least I think I do. I'm not sure. I've never streamed on YouTube before, so this is different. Okay, so that's there. If I refresh this on that page, there is a live one going on. It's muted. Ah! There it is. And then I can do this one there. Yay! Okay, I think it's working now. New problem. Oh no. No, just show the question. Alright. So if you needed to pause the video later, it's right there. That is some bad stream quality on. Okay, that's fine. Alright, so. Working on a second proof. They gave us a beautiful trapezoid with 2 diagonals in it, which we will learn about more trapezoids later on in the school year. And we have A, B, C, D. And we have the letter E in the middle. And so this type of proof is one where everything is filled out on my screen except for one statement and the reason. So that's all I'm going to go for. So we are given angle AC, or sorry, line segment AC and line segment BD bisect each other. And so that's the given. Now, the next step they gave us already, which is going to be AE, is congruent to EC. And they say segment bisectors. So AE, this side, and this side. Well, just thinking off the top of my head with this, most likely, and this is where we're missing the next step. So we're missing that step. The following step after that is angle BEC is congruent to angle DEA by vertical angles. So that means B to E to C. So this one and this one. And then finally they say that the 2 triangles are congruent. So they say triangle BCE is congruent to triangle DAE by side angle side. Well, if I look at this, right, side angle side, here's my angle, here's my side. That means I'm missing a side. Well, I want ED to be congruent to BE. So I'm going to say BE is congruent to ED, and the same reason as above, segment bisector. So now if I type this into my nice, beautiful computer program, BD, oh no, BE and ED, and then I say bisector, BIS, pulls it right out for me. Hit submit, and it works. So that is a type of proof that I'm teaching my students right now. My next type of proof I'm going to go over is a really interesting one with this program. What it is called just reasons only. So it actually just lets you work through a proof without actually having to come up with every single statement. You just got to come up with the reasons. So, we are given AE is parallel to DF, and AE is congruent to DF as well. And finally, we are given AB is congruent to CD. And we need to prove that the triangle EAC is congruent to triangle FDB. All right, I'm going to draw the picture now. We have a line here, line here, line here, line here, line here. Going to label my picture. A, B, C, D goes along here. A, B, C, D. E's up top. F's on bottom. And so that's statement number 1 with a given as a reasoning. And I go ahead and I'm going to label everything in red that they said. So we know that this and this are parallel. And we also know that they are actually congruent too, which is really, really nice. And then we also know that this angle and this angle are congruent. Now, we know in geometry that there are 4 main triangle congruencies. And then there's HL off to the side because that's a special one used for only right triangles. So this one, we have an angle, we have a side, which means it's not going to be side, side, side. It could be any of the other ones. Well, in my proof that's already written out, we have angle A is congruent to angle D. Now, I just have to say the reason why. And once again, this is going to be... Why? I forgot to mark one extra thing. This piece and that piece are congruent. So, why does angle D and angle A? Well, if you look, if you just turn your head a little bit to the left, you will see that these are alternate interior angles. So, alt interior angles. Because they are a transversal through a parallel, interior, boom. All right, so that was true. The next statement that the computer says is BC is congruent to BC. I love that one. That's one of the easiest ones. That is just reflexive. Reflexive. So for my reasoning, I can say reflex, type that in, and I get part of it done. Now, we are going to do next thing that the computer says is AC is congruent to BD. So we want this one and this one. And the reason is because the addition of congruent parts. Since AB is congruent to CD and BC is congruent to BC, since you have 2 things that are the same and another 2 things that are the same, if you added the 2 things together, it would be exactly the same. And so luckily, this program just says type in add and it'll come up with the rest, and it's called congruent segments added to congruent segments form congruent segments. That's a lot. And finally, finally, they said triangle EAC is congruent to triangle FDB. Now we just got to pick one of these four. Well, let's see here. We have an angle and two sides. So that means it could be just side, angle, side. Because that's the only one that has two sides in it. So we're going to say SAS. And you can see that because this is a side followed by an angle and another side. So if I choose SAS and hit complete, it gave me credit for it. So yay. Now, I'm going to move on to the last question for this week's homework. At the moment, unless you have a question, you could always just send me a message on Remind. My last question is going to be about Pythagorean theorem, and then I'm going to move on to some algebra math instead. So question number 4 for tonight. You are given 2 points, 6, 1, and the point 3, 5. They want to know find distance radical. Now, there's a couple different ways you could do this. First, wow, voice crack. First is the distance formula. So distance equals x2 minus x1 squared plus y2 minus y1 squared. And if I just label x, y, y. All right, I just got a question. I'll answer it in 1 second. So for this one, I would just plug into my formula. Notice how I pre-write my formula, and then I just add in the colors when I need to. X, it does not matter which one as long as you do the same first. X2, I'm going with the second point. It makes sense. And then the same thing for the Y's, which means now I'm going to do some math. 3 minus 6, negative 3 squared, plus 5 minus 1 is 4 squared. Oh, this is going to be a perfect square. 9 plus 16, 25, and the square root of 25 is 5. Wow, that one you didn't even have to do anything. But just remember, if you had, I don't know, let's say the square root of 50, that's not simplified. To simplify it, you would factor tree it, 2 and 25. And then you'd factor it again, 2, 5, and 5. You would look on the very bottom row and say, oh, there's a pair of 5s. You take one pair of 5s out of your dresser, and then everything else stays inside the dresser, so square root of 2. So I had a question. Let me open up my phone. For side, and side, angle, side, and all that, how would you know what to consider a side or an angle to check them off? So if I go back here and look, I'm actually just looking at each one. So this one has an angle symbol. So I know that's going to be an angle. This one has a line segment symbol. So therefore I know it's going to be a line segment. And finally, the last one here, once again, has a line segment. So another easy thing you can remember is, let me scroll down. So remember, side, side, side means you're going to have 2 triangles where you have all 3 sides that are the same. The next one we have side, angle, side. And this is where sometimes you just need to write it down. So once again, we still can have a side here and a side here. The angle has to be in between it. Like so. And then of course, if that's not the way your triangles are, you can always just physically turn your paper to see if it works that way. And then we have angle, side, angle, which once again, drawing your pictures and color coding big time. You need to have an angle, the side has to be in between them, and then you would have your other angle like that. And once again, you could just turn your paper, you know, whatever way you need to. And then you can see it. And the final one, and then we are going to move on to some algebra questions, unless somebody has a geometry question right now. Let's see here. Angle, angle, side. So once again, angle, side is the really odd one though, because what it is you have an angle, then you go along one of the sides and you can draw another angle. Angle, angle, and then a side. The side can't be between them. It has to be on the ones next to them. So now I'm going to try some algebra, which is going to be a little interesting because my first algebra ones are about solving systems of equation by graphing. Luckily, Microsoft OneNote, very nice. I can just switch it over to graph paper real quick. That'll help out a lot. So this is question number 5, or the first one for algebra. So I'm going to just write algebra 1. If you have a geometry question, though, feel free, once again, ask me. I will be more than happy to go over it. So algebra question number 1. Graph and solve. Oh my gosh, I cannot write today. So we have 2 equations here. Y equals negative 1/2 x plus 2. And our second equation is 3x minus 2y equals 12. So I've used the blue color and the green color a lot to demonstrate these. So I'm just going to do that because the green one I got to manipulate actually. The blue one is already written in slope-intercept form. And you remember, y equals mx plus b. That's our slope-intercept form. Where b is your y-intercept, you'll see m is the slope, rise over run. So, for our first equation, m equals negative 1/2. When you have a negative slope, that means you are going to go down and then to the right. Our y-intercept, b, is equal to 2. So I'm going to zoom out just slightly, and I'm going to make our beautiful graph right here. So here is my XY chart. What I'm going to do is count boxes by 1. I'm going to go up 2 on the y-axis. So here's our x-axis. Here's our y-axis. I'm going to go up 2 from the center, and I'm going to put a blue dot. My slope says go down 1 box, then go right 2 boxes. So I'm going to go down 1. Then 1, 2 to the right, down 1, 1, 2 to the right, down 1, 1, 2 to the right to get a nice beautiful line. I can also do the inverse going left, so up 1, then over 2, up 1, over 2. What that allows me to do is make it so then I can draw my line better. Because the more dots you have, the easier it is for you to make a straight line by yourself without using a computer. Now, for the green equation, it's not written in slope-intercept form. So what I need to do is get the y by itself. So I call this house method. Just something I've done where you draw a house around the letter that you want to get rid of, or the letter that you want to stay. In this case, we want the y to stay, so we get rid of what's furthest away, which is going to be the 3x. So I get rid of the 3x by subtracting because it's a positive. We're left with negative 2y equals, I really like the fact that most of my classes are deciding to put the x first, so then it is already in slope-intercept form. So negative 3x, and then that's a positive 12. House method again. We need to get rid of that negative 2 by division. And whenever you divide, you take the sign with you. So that leaves us with y equals 2 negatives make a positive. I can't do 3 over 2, so I just leave it 3 over 2. A positive and negative make a negative, and 12 divided by 2 is 6. So that's my green equation now. And once again, it is now written in slope-intercept form, so I can say m equals 3/2. This is a positive slope, so it's going to go up and then to the right. And our b, our y-intercept, is -6. So I'm going to zoom out again, go to my graph. I'm going to go to -6 on the y-axis. 1, 2, 3, 4, 5, 6. My slope says to go up 3 boxes, then go to the right 2. So 1, 2, 3, 1, 2, put a dot. 1, 2, 3, 1, 2, put a dot. And there we go. I have now graphed it. Our program that I use makes it really easy to graph this. And then you just have to say what the solution is. Well, the solution is where they cross. And at least for the program I'm using right now, the solutions are going to be at least very visible, meaning there's not going to be halves or quarters or anything. So this one, remember your x goes first, which is 1, 2, 3, 4, comma, 0. So there is our graphing of a system of linear equations. Now next up on this week's classwork assignment is substitution. And once again, if you are joining in and you are on, you can just sit there and watch, or you can ask a question, your choice. I know there's 4 of you watching right now, so feel free to send me a message on your homework or classwork if you need help. All right, so going down to the second one, I'm going to switch my paper over to lines again. Hey, look at that. I was dead on for that one. That is amazing. So number 2. So we want to solve by substitution. Solve by substitution. So we have 2 equations. Y equals 2x. And the other one, y equals 10x minus 16. Now, since both of these equations have the letter y by itself, we're just going to set them equal to each other. What I mean by that is this blue circle represents the letter y. I'm going to substitute it in for this y. So instead of that y, I'm going to put 2x equals 10x minus 16. And I'm doing that because I can't solve a problem when there are 2 variables. I can solve it when there's just 1 variable, but now I need to make them all on the left side. So we have 2x on the left, 10x on the right. House method, we want to get the variables on the same side. It's going to be easier just to move this 10 to the other side. And now we have 2 minus 10x, which, saying over and over again, 2 minus 10, keep, change, flip, if I can write correctly. They are different signs. Different signs we subtract. So 10 minus 2 is 8. The 10 is bigger. So it's going to be a negative 8x equals negative 16. Now, we are going to divide by negative 8. Divide by negative 8. We get x equals 2. So our solution is going to be, our x is 2. And now we have to find the y. In order to find y, all we're going to do is plug that 2 back into that circle. So y equals 2 parentheses 2. Y equals 2 times 2, 4. 4. And there we go. That was a level 1 substitution problem. And now we're going to move on to the second level. Once again, if you have any questions, just send me a quick message on Remind, and I'll be more than happy to help you. So our third question. Let's see here. Once again, it is solving by substitution. So I'm just going to write substitution. And this time it's going to look way different. So negative 7x minus 10y equals 40. And x equals negative 2y. I need to space that out slightly better. Alright. So this time the x can equal something. Since the x is by itself over there, I'm going to take that blue circle and bring it all the way in for this x over here. So if I write down my equation, negative 7 parentheses, negative 2y minus 10y equals 40. I'm going to multiply first. Negative 7 times negative 2 is 14y minus 10y equals 40. Combine like terms. 14 minus 10, 4y equals 40. And then lastly, I'm going to divide by 4. So y equals 10. Cool. So I can say my solution. This time we're looking at y, so that number goes second. And we're going to plug that in to the other one. So x equals negative 2 parentheses 10 close parentheses. X equals negative 20. Negative 20. And there's our solution. So, that is all that I was planning on going over at the moment. If you have any questions, feel free to send me a message. I am going to take a quick water break. And I will be back in about 5 minutes. If I don't get any questions, I'm going to end this stream here for today. And thank you for joining in if you need anything. So, I'm taking 5-minute break. A person just sent me a message about literal equations. After I take my 5-minute break and go get some water, I will answer that question in a moment. It's a very interesting question. So 5-minute break. Be back at 6:45. So I'll be right back. All right. I got some water. I'm refreshed. So we're going to start doing a couple literal equations because literal equations are a pain. It's just asking you to practice a lot of your house method skills. So here we have an equation, negative BA plus 9 equals Q squared A. And they want to get A by itself. So the first thing we are going to have to do is make sure A is all on the same side. I'm going to leave that 9 alone. And I'm going to add BA to both sides. This way, all the A's are on one side. So 9 equals Q squared A plus BA. Now, from here, I'm going to actually unfactor. Right? So both these have an A in it, which means I can take an A out and put in parentheses the Q squared and the plus B. I'm only allowed to do that because if I multiply A times Q squared, I get Q squared A, and A times B equals BA. So it is mathematically 100% accurate. Then, since I want A by itself, I'm just going to divide by the big, ugly parentheses. And that leaves me with 9 over Q squared plus B equals A. And so now the A is by itself. These are a pain because there's no like number math you're doing. You're just manipulating the equation. Now another example following this, we're going to solve for A still. So I'm going to scroll down. You can always go back and pause the video there. Solve for A. The equation is B squared equals negative G plus 1/8 RA. So once again, we're trying to get the A by itself. So right now, the furthest thing from the letter A in that house is the letter G. So we're going to get rid of the G by adding. Now, B squared plus G, you can't put those two terms together. So we have B squared plus G equals 1/8 R times A. So if we draw our house again, we want the A to be by itself. Since these are both multiplication, we can, hey, eraser, we can divide by both letters at the same time. And this is where it just gets annoying. Because you can't leave a fraction inside of a fraction. And we would have A. So let's see here. What I like to do instead is B squared plus G, right, divide by 1/8 R. Now we kind of got to make that a little bit easier for us to understand. So what we're going to do is, since we're dividing and there's at least one fraction, we're going to make sure that the first thing is a fraction divided by 1/8 R. What I'm going to do, I'm going to move the R up top. Because 1/8 times R is just R over 8, or 1 R over 8. And now I can do my keep, change, flip. So I'm going to keep the first fraction. And then I'm going to change, multiply by the reciprocal, put the 8 up top, the 1 R on the bottom. So what that means, if we multiply straight across, we have 8 times B squared plus G over 1 times 1R is just R. Which means that equals A. A little complicated, but it works. All right. Since there's only one viewer left on, I'm going to leave everything open for 5 minutes. If you have a question, please feel free to send me a question on Remind right now. If not, I'm going to call the stream at about 6:55, and then I will edit the video so this can just stay up on YouTube. So feel free, send a question. If that's bad, why? Alright, so since there are no viewers at the moment, I'm going to call it there. So thank you for joining in. If you have any questions, you can always message me on Remind. And I will be trying to do this